The purpose of this video is to illustrate the QC Pro SPC software. The software provides the key SPC charts and calculations, as well as two types of data entry. One is a real-time data entry, where you can see the control charts being updated in real time as you enter the data. And the other data entry would be more of a spreadsheet type of data entry, where you just put in a block of data and want to look at a capability study, for example. During the setup of a product, you can put in your engineering specifications and the characteristics that you'll be measuring. There could be a picture associated with each characteristic, and there can be a procedure on how to measure a particular characteristic, telling the operator how to measure that characteristic. You can also externally capture data through various measuring tools like calipers and micrometers and all sorts of other tools. And there are some custom fields that can be defined that are unique to your company. We'll illustrate all of this during the setup of a particular product. As far as reports are concerned, just a generic type of reports that would be of use, things like control charts, whether it be an X bar and R chart, or an individual and moving range chart, or a moving average and moving range chart, or an X bar and sigma chart. All of those charts are available if you wish to generate them. And then of course you can generate capability studies with histogram. You can also generate a management type of report for CPKs, where you can have sort of a summary report for the different products and their characteristics. And we can also generate a defect type of analysis using what's called Pareto, where you order the defects from worst to best if you want to record defect type of information. In terms of flexibility of reporting, you can filter on various things, like a date range, like give me the report from let's say January 1st to May 15th, if you want to do something like that. Or on the user-defined fields, which we'll see in a little while, you can say, okay, let's say we set up a field called shift, and you're only interested in the analysis based on shift number 2. So you'd be able to identify the capability, CPK values, and so on, or a control chart based on the shift, let's say shift number 2. And so that's sort of the general makeup of the software. What we'll do now is we'll go through the exercise of setting up a product, or adding a product, and the various characteristics. And to do that, we would, there are one of two ways. There are a set of toolbar buttons up here. This particular toolbar button would advance us to the product detail window. Or we can go through the menu system. If we go to File, Products, that'll also take us to the same place. And so now we're in the product detail window, and we're adding a new product. With the cursor flashing in the product ID, we'll type in the product ID. So for example, let's say it's this product is the ID. And the description of that particular product, let's say it's a rear lamp. Maybe housing. Okay, and so that's sort of the description of what we're going to be looking at. Well, actually, let me just correct this spelling error. And then we'll go ahead and save by clicking on the toolbar button here in the top left. So that puts that in the database now for various products, and we can now set up the characteristics that we might want to measure on the rear lamp housing. So for example, let's say the first characteristic would be the width of that housing. And the unit of measure, it might be in inches, let's say. And the upper spec, well, let's say the upper spec is 4.250. Actually, make it 4.251. And the lower spec, let's say, is 4.249. Okay, so we have basically a spec of 4.250 plus or minus 1/1000th of an inch here. And the other items here, the base and the multiplier, we're not going to use them in this example, but if you're keying in a lot of measurements, you can use this. For example, if we set the base to 4.250 and the multiplier to 0.001, then to enter a measurement like 4.252, all you have to do is type in 2 and it'll automatically convert it to 4.252. And so that takes care of setting up this particular characteristic. We'll just click on the Save button in the top left corner. When you do that, you can see that it's added that characteristic to the list of characteristics. There's only one at the moment, from which you can recall a particular characteristic. If you want to edit a particular characteristic, you double click on it and you can edit whatever you need to edit. So for example, I made a mistake here on the lower spec. I forgot to put in a decimal place after the 4, so I'll just go back here and I'll press the decimal place and then save that. So now we've got that in there correctly. And let's say I want to set up a second characteristic. So I would position the cursor in the name field for the characteristic, and then I would click again up at the top. We have some toolbar buttons. This one is the new button. These toolbar buttons are context sensitive, which means depending on where you are on the screen, they'll do what they have to do. So we're in the name field for the characteristic and we press the new button. It's going to remove or clear whatever's there so that we can enter a second characteristic. Let's say the second characteristic is going to be height. And the unit of measure will remain inches. The upper spec in this case, let's say it's 6.750 plus or minus 1/1000th of an inch. So 6.751 would be the upper spec, and 6.749 would be the lower spec. And again, we're going to leave this alone. We'll click on the Save button in the top left corner, and now it adds the height characteristic to the list of characteristics that are associated with this particular product. You can also add various, well, actually, before we start adding, let's look at some of the things that we can adjust. So for example, right now we're on the height characteristic, and so down below here we have various things that we can add or enter information for. So for example, a chart. The type of chart that we're going to want to perform on this particular data set for height, we'll just leave it at X bar in our charts, but you see the other charts that are possible if you wish to analyze the data in another way. The subgroup size is set to 5. You can change that. So for example, if you only want to take one reading, let's say at 9 o'clock in the morning, and then another reading at 10 o'clock in the morning for height, we would change the subgroup size to 1. And probably the chart that we'd be using would be an individual's moving range chart, or a moving average and moving range chart if you wanted to calculate averages as well. But that would be this chart. But for now, we'll just leave it at an X bar chart, subgroup size 5. You can also manipulate the control limits on the control chart. By default, they're going to be calculated based on the data, but if you wish to, you can specify it if you wish to. And so that's the chart aspect. You can also put in some notes here related to that particular characteristic of height if you wanted to say something about it. Now, as far as the tab called Procedure, this allows you to actually put in a detailed instruction for the operator if you're going to use the real-time data entry aspect of the software, where they're going to actually enter 5 height readings. You can specify how they will actually measure those height dimensions. And so if you wish to enter a procedure, you would put in the procedure ID, for example, P-1, and then you can just start typing in a free format manner You could say, for example, place lamp housing in testing fixture TF-1, and then maybe the second instruction would be move probe to housing edge, and so on. You get the idea. And so now we'll save that procedure along with this characteristic called height. And so when they go into data entry, the operator goes into data entry for this, they'll actually be able to recall this instruction on how to measure height. You can also associate with a product a picture of that product. And so if you were to store the product as a, for example, the picture as a JPEG or any other graphic file, you could then connect to it. So for example, if I have a folder here called pictures, and I have a picture of a rear lamp, and so we'll use this and save it along with the characteristic along with the product, which will then show up in various places. In data entry it'll show up. It'll also show up on some of the reports, like if you generate a control chart, it'll also show up there, and so on. So that's pretty much the picture. And then you have some additional tabs here. There's the possibility of setting up an equation. So we're measuring, so far we measured width and height. Let's say we want to calculate the area of this lamp fixture. So since we have the width and the height, if you multiply the width times the height, that'll give you the area. So for a third characteristic, we could set up a characteristic called area, and then go into the equation part of the system here, and we could say, okay, let's take the width and multiply it by the height, and that will give us a third characteristic, which we haven't set up yet, called area. So that's sort of the equation tab. And then in addition to that, you have a tab here called custom fields. So these custom fields, their purpose is to allow you to add up to 5 user-defined fields that are unique to your operations. These fields can then be used to filter the data. As an example, if you were interested in analyzing data for a particular shift, as we mentioned earlier, then you would specify the shift, and the resulting report would be based on the selected shift. So in this case, we have 2 additional custom fields that we've set up already. One is called operator and one is called shift. So if I were interested in a analysis of data based on a particular operator, because maybe we think the operator might be influencing the measurements, which is not good. But if we were interested in that kind of analysis, we would be able to say, okay, give me a report for, let's say, operator Frank, and that report would then reflect Frank's measurements over the various days that he has worked. So that's what custom fields are all about. Now, these custom fields can either be set up uniquely for each product, or you can set up the custom fields so that they're the same for all products. And that would make the most sense, because you might be interested in looking at a particular field or shift, for example, and that shift might be of interest not only for this product and this characteristic, but for other products and other characteristics as well. So generally we try to keep the custom fields applied to all the products. And in that case, there's a place where you can actually go through a settings. If you go into settings, you'd be able to apply that to all your products. So that pretty much. Oh, and then we have another tab here called Attribute. So one can set up not only measured type of data, but also data that's associated with defects, for example. And you might want to count up various defect type of occurrences. So for example, if our housing, our lamp housing, had some burrs on it, and you wanted to identify, we had 3 burrs on this particular housing, or there was a crack in the housing, and you want to record that, that would go into the defect. First of all, you would set up these defect names, either unique to this product or generally associated with the entire database. But the point is, you would count them up, and then later on you could be able to get a report that would show from worst to best the number of times, let's say, burrs occurred, the number of times cracks occurred, and the idea would be to focus in on the worst offenders, which is the Pareto principle of looking at the worst and kind of focusing your energy on that. You can also assign a picture to the attributes that you're looking at, so for defects. So in addition to the picture of the housing lamp, let's say you want to look at a particular spot on that housing lamp, you would click on this picture button, and if you had a JPEG, it would show up. So that's the story of how to set up a product and their various characteristics, and sort of manipulating some of these tabs down here. And the last thing I'll mention is this product memo. Once you're in full swing and you're actually working and collecting data, and if you're doing it in real time especially, you can, in addition to everything else, you can have a little memo here that pops up on the screen in data entry, which we'll get to in the next segment of our video, which can just alert the operator of something. For example, let's say you had a shipment from your supplier that had some problems with the raw material. So you could type in here, some free format things, telling the operator to please pay attention to shipment, XYZ, and take corrective action if necessary. So that's pretty much it now for the product setup, and we'll kind of stop here, and we'll continue in a moment with data entry. We're going to focus now on the data entry segment of the software. There are actually 4 different ways of entering data. The first would be to have what we call operator mode, where it's real-time data entry with a control chart being displayed in real time. The second way would be sort of a block of data that you just want to enter, like maybe 50 or 100 measurements at one entry. We call that the power entry mode. And then another type of data entry would be more for attribute type of data, where you're looking at visual defects, for example, and you want to count up those defects and analyze that kind of data using what we call a Pareto analysis. And the fourth approach is to transfer data, to import data from an external file like an Excel spreadsheet. But we'll illustrate all of those bits and pieces. But first we'll start out with the probably the more likely approach to data entry, which is what we call operator mode, or just real-time data entry. And we can get into that data entry by either clicking on the toolbar button called data entry, or we can go through the file menu system and we'll go down to data entry this way. So this brings up one of the products that we have in our database. If this is not the product that you're interested in, you would click on the Find button, toolbar button, and you can sort of pick the product that you're interested in, or just type in the product ID here. But why don't we stick with this product? Now, you'll notice that this particular product, before we start entering any data, there's actually a memo here that's been sent to the operator out on the shop floor. So this would be a free format memo that is to get the attention of the operator, so that that they're aware on every shift, and whoever is actually working on the product and taking measurements would be aware of whatever the issue is. In this particular case, management has sent out a memo to the operator indicating that there have been some problems with the diameter dimension from their customers complaining. So that's sort of something that can be done in real time, and this can change at any point in time. Or if this is not what you want to see on the screen, you can also show, in addition, in place of this, you can show a picture of the product or the characteristic that's being measured as a JPEG. Also, down below here we have the control chart. This will be, we're actually plotting an average and a range chart, and there's some data already in here. There are 1, 2, 3, 4, 5 averages made up of 5 readings per subgroup. Subgroup size is 5, and that was set up ahead of time, and we're now on subgroup number 6. The coloring here is related to zones. The green zone is sort of an acceptable area for fluctuations in averages. The yellow zone, once in a while, will have averages in the yellow, and the pink zone. The red zone is actually beyond the expected amount of variation for averages. We would call that an out of control point, statistically speaking. So if there's a point that exceeds the upper control limit for averages, which is this red zone, that would be a sign of some specific issue that needs to be looked at and taken care of before we continue with production and taking data in the next time around. There'll be a message actually that appears up here if there are any statistical rules that are being violated. Some of the more common statistical rules that the software employs would be obviously a point outside the control limit, either for the average or for the range chart. If you have 7 or more points increasing, 7 or more averages increasing, that's a sign of something that is unusual, like a trend forming. So again, there would be a message appearing up here. So that's pretty much the general background. Let's start entering some data. This particular product has 2 characteristics we're looking at. We're looking at the length and the diameter. It happens to be a camshaft. And for the length, we had set up the specifications to be 6.995 for the lower spec and 7.005 for the upper spec. So as we start entering measurements, for example, let's say we enter a measurement like 6.999, that appears in this, well, I guess you could call this sort of a macro gauge. It's not really a gauge, but it sort of represents a gauge. Where the green things that are lit up here, these rectangles that are lit up here, sort of tell you where you are in the spec range. So we can see for a value, for a measurement of 6.999, we're roughly in the middle of the specification range, which in turn is indicated to us as being a pretty reasonable part with a green light. We're using sort of a traffic light here, red, yellow, and green. Red being out of spec and yellow being sort of close to the upper spec or close to the lower spec. And so if we continue entering some data here now, let's say we have a measurement that's 7.004, which is sort of approaching the upper spec. We see where the measurement falls with these green rectangles being lit up close to the upper spec, and the traffic light is turned yellow, which means we're getting close to the upper spec. So it's kind of a visual feedback for the operator as they enter measurements. Let's say we are out of spec with the next readings, and so the green rectangular gauge is beyond the upper spec, and it's also indicated to us with a traffic light signal of red. And and also the measurement itself is shown in red in the data entry screen because we're out of spec there. 7.005, so we're just at the upper spec. And let's say 7.006. So we're out of spec again. So these are all indicated with the visual feedback that we get here. And now we'll go on to the diameter reading. The diameter reading is a measurement from 1.995 to 2.005. So let's let's kind of put in some measurements here. 1.999. So that's kind of in the middle, which is good. 1.998. 1.997. So 1.997 is getting close to the lower spec, and again, it's visually indicated with this yellow traffic light. And let's say 1.996 is the final reading. So now, once we've entered our measurements, our subgroup size was 5 for the length and for the diameter. By the way, you can have different types of subgroup sizes. The length could be 5, which is what we have here, but we could have set up the diameter to be 2 measurements per subgroup, or 1 measurement per subgroup, and then it would obviously adjust the what's visible here. So if the subgroup size was 2, we'd only have to enter 2 readings, for example. We also see the average for this particular subgroup and for this particular subgroup of diameters. We've got the current system date. Sorry, not the system date. This was actually the last time they entered measurements. So why don't we put in, let's say we didn't run this product for about a month. So let's say we actually put in today's date, which happens to be November 1st. And the time that we actually took these measurements was at 10 o'clock. Let's say 10:30 in the morning, or 10 in the morning. Let's say we took those measurements at 10. And the person that took the measurements, let's say it was, I don't know, Bill. And the shift happened to be 2. So, and we can also include some comments about the various characteristics. If we were on the length, on the diameter characteristic, we could say something if we wanted to. There's also some corrective action that can be taken if we need to and documented. That's what this is all about. And this is actually set up ahead of time back in the settings segment of the software, which we haven't talked about yet, but there's a place where you can set up these corrective action reasons, the drop down reasons. But let's go ahead and save this, and we can see that for the length characteristic, which is what we're on right now, there's a point above the upper control limit for averages. This is the point. So for our 6th subgroup, we're now about to enter the 7th. For our 6th subgroup, we actually exceeded the upper control limit, and so it's telling the operator that there's a problem, statistically speaking, with the upper control limit, a point being beyond the upper control limit. And so we would probably want to take some corrective action. And these are the things that we sort of populated our drop-down list with up until now, but we can add things or remove things. Let's say we do this. We take that product that is associated with the 6th subgroup at 10 o'clock in the morning, whatever was produced between, let's say we do it every hour, we're taking measurements between 9 o'clock and 10 o'clock, we would take that production and we'd probably have to do something to make sure that we don't have a problem before we continue with production. And so the action was completed by, let's say, Bill again, and we would go ahead and save that information. So if we go back, if we fix the problem and we record it here as being containing the product, like from 9 o'clock till 10 o'clock, whatever that production is, that will be our corrective action for the moment, or the action for the moment. And then the corrective action would probably be, making sure it doesn't happen again, whatever we need to do to make sure it doesn't happen again. So that's sort of an idea of how we enter data in what's called operator mode, or real-time data entry mode, where we have control charts and you can see on an ongoing basis what's happening to the control chart for averages and for ranges in this case, for each of the characteristics. Now what we'll do is we'll kind of maybe get out of here, and we'll go into a different data entry mode. We'll go into what's called the power entry mode, which is more of like a spreadsheet type of data entry. Now we can either continue with the same product, or let's pick another product for this one, to illustrate this one. Perhaps we'll go to this product here. So this is sort of an external frame that has a length and a width dimension, and unless we specify otherwise, it's going to pick up the current system date and current system time. And if we want to record things like operator and shift, for example, let's say the operator is the initials of the operator IRP, and let's say the shift would be shift number 1. So now we can enter the readings for, in this case, we're in the length dimension, and we can just enter a bunch of readings. If we're doing a capability study of, let's say, 100 measurements, we can enter 100 measurements for length and then 100 measurements for width, and then get our capability study out of the system. So we'll enter a few measurements here. This particular product, the length dimension is a dimension between 7.995 and 8.000. So why don't we just enter a few measurements close to that. And so on. So you could continue entering here as many measurements as you wish. Generally, the way this works is you enter up to 50 measurements, you would click on apply, it would clear everything out here, and then you can continue entering the next 50 and the next 50 and so on. So if you had like 250 measurements, you would go through this exercise 5 times for, let's say, the length. Anyhow, once we've done entering the measurements for length, we would click on the apply button, and all the measurements would now be saved in the database. If we wanted to look at our measurements, we could see them as we entered them. So some of the measurements were entered, I guess, back in September, and then some of the measurements were entered now. The ones for November are illustrated here, and so we actually have 20 measurements in there right now. Actually, this measurement is kind of missing, so let's just put in a measurement here. And so that, save that. And now, if we wanted to, we could enter measurements for the width dimension by double-clicking on the width. And now we're in the width dimension, and in a similar way, we can enter the measurements for width. The width happens to be 2.995 to 3.005, the spec range. And you can just, continue entering measurements as we did for the length, but now we'll do it for the width. Okay, so let's say we'll stop here with this type of data entry. We'll click on apply, and so now we have measurements for both width and for length. In the case of width, if we go back and look at the history, we've entered these measurements for width on September 28th, and then in November we started up again with the production, and we've entered a few measurements, which happens to be November 1st in this case. So that's what we call our power entry mode, and so that's the second way of entering data. The third way of entering data is through an external spreadsheet, for example, where you want to import data, like an Excel spreadsheet. And the user guide talks about this in detail, but basically you would identify, first of all, what you want to do with the data. We want to import data. You can also take data and export it, but we're going to bring it in. and then you identify the name of the spreadsheet and the where the workbook is found. So we would have to go and kind of browse to where our workbook is, which I'm not going to do at the moment. And that's pretty much it. You would identify where the length column is in the Excel spreadsheet, for example. Let's say it's in column A1, and let's say the width dimension is in column B1. And you would identify the number of rows and you know where you want to start. Sorry, I kind of went backward here. What column it's in, so let's say it's column A. What column the width is in, it's column B. Where you want to start, so let's say we want to start in row number 3, so you would type in 3 here, and you want to end in row number 53, so you would type in 53 here for the end. So it would take all the data from column A3 to column A53 for the length, and column B3 to column B53 for the width. After you click on the transfer button, which we're not going to do. So that's sort of the third way you enter data, is through importing data from an Excel spreadsheet. And finally, for data entry purposes, let's look at an example of an attribute type of data entry. So again, we're going to go to File. We've done data entry operator, we've done data entry power entry, we'll do attribute data entry. And currently it's looking at the product that we were just entering data for power entry for, but let's go ahead and pick another product out of our list of products that are currently in our database. And this will be, it's sort of a tray, the base of a tray, and we have a similar kind of spreadsheet looking thing here. Let's say the operator was Frank, and the shift was 3. Now, the production size, which is the column that we're looking at right now, let's say we produced 1,000 trays during this shift, and we took, out of the 1,000, we took 10 trays. So the sample size would be 10. The number of defectives, so out of those 10, how many were actually, you know, garbage? That's what we mean by defective. So let's say one of them was defective. We had to throw it out. How about the number of defects? So the number of defects would be the different types of defects that we're kind of recording here. So, you know, in our case, we've set up defect categories as displayed by these columns, things like burrs, cracks, missing holes, color off. And so let's say we found 3 defects. One of them was a burr, one of them had a missing hole, and one of them had color that was a little bit off. So this is how we would enter the various quantities of defects that we have kind of set up here. This segment will illustrate the reporting features of the software, and there are really 2 ways to get reports out. We can either use these toolbar buttons. For example, if you're in data entry and you're in a column called length, and you click up here, you'll get a control chart or a capability study for that data. And but another way of doing it would be our data table. Another way of doing it is to go through the report menu system, and we'll do it that way. So we click on report and go to report options, and the first thing we need to do is identify what product we want to report on. So we'll just click on the find button, and through the list here we can identify, let's say, a product. Let's say this one, this particular product happens to be an axle pin, so let's have a look at that. That product has 2 dimensions that we're looking at, 2 characteristics that we're looking at. We're looking at length and diameter. So we can either report on length or on diameter. We'll leave it at the default, which it happens to be length at the moment. We can also filter the data for length. For example, if we're only interested in a particular date range, we can enter the from and the to dates that we're interested in. Or if you had set up some custom fields, which we had done earlier, we had set up two custom fields, one for the operator name and the other one for shift. You could filter on shift, for example, if you're only interested in, let's say, shift number 1, in the from and the to, you would put 1 to 1. Same idea for operator. And so we'll just click on apply here, because we're going to filter on, we're not going to filter, we're just going to get all the raw data for the length dimension. Once we do that, we can look at, for example, the control chart for length. And we'll just make this a little bit bigger for viewing purposes. And so on here you see that there's several things. First of all, we have a date for each of the sampling points, the date of the measurements and the time that we took them. And in this case, the subgroup size happens to be 5. So we have 5 measurements, and the average and the range for those 5 measurements are shown. We can also change what we identify with this data set. So for example, we have a custom field here called shift and name. So we could change this to, for example, instead of date, we could call it shift, and instead of time, we could put in the person's name, for example, which is done in a settings within the software. We can look at the chart, and basically it's just a regular generic control chart where the top chart is for averages. We're plotting the averages. And the red lines, or dotted red lines, or dashed red lines, represent our upper and lower control limits, statistical limits for the average chart. And the blue solid line represents the average of averages, the center line. And if we scroll down just a little further, we have the second chart, the range chart, with its appropriate upper control limit and center line. And if you had put in or set up a company logo, your company logo would appear over here. And if you had set up a picture for this particular product, it would also appear. This happens to be an axle pin, so that's the picture that we see. And if we go back and have a look at the various things that we can do, for example, we can print this control chart just to a piece of paper, or we can send it to a PDF file and then attach that PDF file to, well, first of all, we could print it at a later date if we wanted to, or we could attach it to email, or a regular email, and send it out as a PDF file. You can also do that directly from here. This allows us to email this particular report to whoever you need to email it to. So that would be our control chart, and we'll just close that out. And if we go back to report and have a look at, now sometimes people like to have blank control charts with the control limits and center lines already in there if they're going to do things manually on the shop floor, where the operator would actually collect the data, write it in, and put in the date, time, and the measurements, calculate the average and the range, and then plot those on the control chart. So I don't know if that's still being done these days, but it's not a bad idea to actually get the operator involved, maybe not in the manual way like this, but definitely involved in doing the measuring and also calculating, and to just take corrective action when necessary, because they're doing it in real time as they're manufacturing the product. The other chart that we can get out is the process capability chart for the length dimension in this case. And so we can see here, first of all, we see the lower spec and the upper spec in dashed vertical lines. So that would be these numbers here for the upper spec and for the lower spec. And we're also calculating here the number of measurements that occur in a particular cell of a histogram. These boxes represent a histogram. So for example, in cell number 1, we have 2 parts out of the 50 parts that we looked at that fell into that particular category, where the lowest measurement, lowest value is this and the highest value is this. So 2 parts fell in here, and in the next cell 4 parts fell in, and so on. So we have a histogram, or sort of a representation of our measurements, a visual representation of our measurements through a histogram. And then we can do some statistical analysis and develop a smooth bell curve over our histogram if it happens to be a normal distribution or a Gaussian distribution. And so we've done that here. And the average value is 5.0. The standard deviation is 0.0013. So if we take our average, which happens to be 5.000, and we add 3 standard deviations, it takes us to the upper tail of this bell curve, which is the predicted, what we call the predicted upper limit, which is 5.004. And if we subtract 3 standard deviations, it takes us to this lower tail, which is the predicted lower limit. So this represents what we expect our production to produce, and measure product as low as as high as 5.004 and as low as 4.996. And of course, the other indicators that are of interest would be things like Cpk, which happens to be 1.52, and Cp index, which also happens to be the same number. Usually they're a little different, but this particular distribution is so well centered between the lower spec and the upper spec that they actually happen to be the same value. We also calculate Ppk and Pp index as well. And so that would be the capability in this index, the capability analysis for the dimension called length. And in a similar way, we have another dimension called diameter, which we could have shown here, but we'll just leave it at that for now. So that's the capability analysis. We'll close that out and we'll go back to reports. We can look at the data set that went into this particular thing called length. And so our readings, our first 10 readings would be shown here, and so on for the next 10, and so on. And so that's our data table for this particular product, for the length dimension. The other thing we can look at is a Pareto analysis. If you're looking at defect categories for this product, you can count them up. So for example, we had produced 11,000 products, of which we took 220 and we looked at them, and we found 51 of them with various defects. And the defects that we found were these items here that are listed. We found burrs, surface marks, color off, and so on. In the case of burrs, when we counted up the number of burrs, we found 25 burrs on the 51 items that we looked at. So if you were to work out the percentage of, how many, what is the percentage of burrs out of the total number of defects, so it's 25 divided by 51 times 100, gives us this percentage here for the defect called burrs. And in a similar way for surface marks and so on. The other thing that might be of interest is out of the 25 burrs, what is that, compared out of the sample that we took. So we took 220 items and we found 25 burrs. So 25 divided by 220 multiplied by 100. So we're saying that 11.36% of the total sampled product had burrs. And then the other thing that might be of interest is out of the total production, out of 11,000, what percentage had burrs? So 25 out of 11,000, it's 0.23% had burrs out of what was produced. And so that's what these columns represent. The other approach is to look at it from a parts per million approach. So if you're looking at production, we produced 11,000, so it's telling us 2,273 of our products would have burrs on them, which is not very good, but that's what it's telling us. So that's pretty much it for the types of charts that you can get out of the system. The last report that I wanted to show you is not specific to this product that we've been looking at, but is more applies more to all the products, or for whichever selected products you want to look at. It's called the Capability Summary Report, and it illustrates the Cpk and Cp index and Ppk and Pp index and average and standard deviation for the various products that we have in the system and for the various characteristics associated with those products. So for example, the one that we've been working with so far in this reporting segment would be the length and diameter for this product and the appropriate Cpk and Cp index values and so on. Ppk and Pp index are shown here. And that pretty much does it for the reporting segment of the software. Thank you for taking the time to watch this video on the QC Pro SPC software.